Hey everyone, happy question show time. Your questions, my answers. So whenever you're watching any of my videos, if a question pops into your brain, just take a second, just type it into the comments. I will gather them up and I'll answer them here. All right, let's get into it. Chiranjan Bagdi. Can a moon be in a geostationary orbit? And if so, then it will never drift away or crash into the planet. Great question. Yeah, so you could absolutely have a moon be in a geostationary orbit. And so just to give you an idea, the geostationary orbit is the place where all of our communication satellites orbit. And it's a place where their orbital period exactly matches the amount of time that it takes for the Earth to turn around once. So that it appears from any spot on Earth that the moon is the satellite is perfectly positioned in the sky all the time. And in fact, that is this line. If you come closer with a moon, then the planet is going to be turning, or the moon is going to be going faster then the planet is turning. And as we mentioned before, when you get that situation, then you get these tidal interactions where the planet interacts gravitationally with the moon. And if the moon is closer than this geostationary area, then the moon spirals inward and the planet's rotation speeds up. If you have the other situation, if it's beyond the geostationary orbit, then and this is the situation that we have with our own moon, the Earth's rotation or the planet's rotation slows down and the moon drifts outward. And of course, if you have it closer and the moon is spiraling inward, eventually it's going to crash into the planet. So that's bad to have. And if you happen to have a moon that was perfectly balanced at that spot where it exactly matched the amount of time it took to rotate around the planet, then it wouldn't move closer or farther. So it would be perfect. Kalankit Hasina. Can we detect black holes using Hawking radiation? All right, so for people who don't know, Hawking radiation is this theorized radiation particles that should be seen coming off of black holes. And it's because there's these virtual particles that are popping in and out of existence across the universe, and normally they pop in, they bounce into each other, annihilate, and disappear. But if you can get this situation where one appears on one side of the event horizon of the black hole and another one is on the other side, and one goes into the black hole and one goes out into the universe, then you should see these particles. And the answer is, like, theoretically, I mean, the vast majority of these are going to be photons. They're going to be seen as heat, as light coming off of the black hole. But the problem is the amount of time, how often these happen is incredibly long. We have to wait for quadrillions of years until the universe is cold enough that these supermassive black holes are going to start to evaporate. Right now, it's still just too warm. And so there's just too much particles floating around in the universe and going into the black holes for them to even start to evaporate. But you should occasionally see this situation where a photon of light would bounce up, come out of a black hole. But it'd be really hard to know that that specifically was Hawking radiation and not just regular light that was coming from a region that was really, really close to the black hole, or just the cosmic microwave background radiation. So we're going to need other ways to see black holes. Michael John Little. After more than 50 years of serious searching, SETI, and not finding them, instead it would be better for us to accept that they do not exist. We are unique in this universe. I don't think that you can describe the attempts at SETI so far to be a serious attempt at trying to find aliens. Like, when you think of the number of stars that are out there right now that are within the range that we could detect signals coming from them, the vast different frequencies that we could be scanning on, and the different times that we could be doing this. You know, each star has to be analyzed individually across all the different frequencies that the alien civilizations might want to use, and for long periods of time, so that you can catch any messages that they send. And the percentage, the amount of the sky that has been analyzed at that level of detail is minuscule. So it is not fair to say that we have done a very comprehensive search for SETI. But even so, it's like, if you could happen to detect an alien civilization with one of your radio dishes, it would be the shortcut to finding that there are aliens out there. The hard way is for us to build these gigantic telescopes and analyze all of these worlds and figure out which ones have biosignatures and send spacecraft to these other worlds to find out what's there. Like, it's a lot of work. And to just happen to receive a signal that provides a bunch of useful information would be amazing. And we could begin having a conversation with an alien civilization right away. You know, obviously we have to wait for the travel time there and back. So I think that the whole point is that we want to look on all of these simultaneously. Let's search for biosignatures. Let's listen for alien signals. Let's search the solar system for examples of alien life. Let's look for, historical artifacts that might be from alien civilizations. Let's use every trick at our disposal to find out, to answer this most important question: are we alone in the universe? I want to know the answer, and I don't want to just give up because it's kind of hard and we've tried a bit. Who's first? Do you have to address us, the audience, as if we're 11 years old? When I write the scripts and when I do the episodes, I try to aim for a certain level of technical sophistication, right? Where people are familiar with a lot of the technologies, a lot of the missions, a lot of the underlying science that's going on, but at the same time, they're not necessarily experts, and they probably aren't that familiar with doing the math for these various equations. So I kind of need to be able to talk around that kind of stuff. And at the same time, in every episode, I specifically go out of my way to add a bunch of stuff that even the people who are really knowledgeable about this are going to be surprised and learn some new information. But I mean, you don't have to watch these videos, right? There's a ton of channels out there who are, a lot will aim at a much more technical level. Like if you see PBS Space Time, Matt O'Dowd, he's a PhD astronomer, does a great job. His stuff gets a little more complicated. Fermi Lab does an amazing video series. I highly recommend that. Scott Manley, if you're into spacecraft stuff, he'll go into talk about the specific impulses of different rocket systems. So I think that you can find the YouTubers that match your level of sophistication, and if these are too simple for you, you shouldn't be watching them. And that's what's great about YouTube. It's a big place. You can go anywhere you want. Martin Wilk. In a binary star system, a planet would have two suns. Sometimes both of them are visible, and sometimes one or the other. Other times, neither of them. How would you define day and night if you have two suns? Is day whenever one sun is above the horizon? Would it make a difference if one of those suns was much brighter than the other? I think that's a fantastic question, and the reality is that you would need a new name. Right? Astronomers, people who, just regular people, would go out during the day, and they would have names for those different combinations. Here we have day and night, and we have names for twilight and sunset and sunrise, right? And just because we only have one star. But for them, they would have all kinds of different combinations when you think about it. There would be times when you had both stars that were in the sky at the same time, and they would have some name for that. And then you would have a time when the one star is in the sky but the other one isn't. They'd have a name for that. And then vice versa, when the other stars were around. And then you'd have times when, really special times where one sun was on one horizon while the other sun was on the other horizon. Times when both were lined up and having sunset at the same time. Times, if they were in any way lined up, when one transits in front of the other. It would be a really fascinating, almost anthropological conversation to talk to these people and go give us all the names for what the stars do around your world. I would love to hear and sort of see how some civilization would do that. So I think that's a great question. And any science fiction writers out there, if you are going to come up with a planet with multiple stars, think about how the civilization will interact and talk about the different times. They'll have names for all this stuff. I love it. Sniper Squad 100. Can blocking the heat from the sun up in space help prevent global warming? Absolutely. If you could block light from the sun to some degree, you would decrease the amount of radiation that falls on the planet, and you would decrease the global temperature. In fact, one way to terraform Venus, for example, would be to put a big shade in front of Venus and cool down, block all the light from the sun and cool down Venus to the point that it gets so cold that the carbon dioxide atmosphere freezes out and snows down onto the surface. And I don't know what you do with it. You scoop it up or bury it or something. it's still there. But here on Earth, right, you could set up some kind of shade, and you could block some percentage of the sunlight, and you could cool down the planet and just keep building more and more shade as the planet is heating up, as the sun is expanding, to try and keep the temperatures perfect. The problem, of course, is that it is a geoengineering project that is well beyond anything we could do currently. Although there are some ideas to do it, putting particles up into the atmosphere that we could probably pull off, but always these kinds of projects are going to have unintended consequences. You think you're going to prevent global warming, but it ends up affecting the weather systems and affecting the atmosphere and the growth of plants and all kinds of things in ways that you never anticipated. So geoengineering should be considered this last resort that we do if everything else is going sideways and we need some way to get our planet back under control or we go extinct. I don't think we should try to attempt it until we reach an understanding of how our planet works, and we are so far away from that today. Anthony Bond. Hey Fraser, I have a hypothetical question. If our universe did not exist and we had the Big Bang over again, would it be inevitable that the universe would evolve in exactly the same way, with gravity forming stars and galaxies, and would this be the same for any parallel universes? The answer is we don't know. Here in our universe, there are a bunch of independent constants. Things like the force of gravity and the alpha constant, and there's like several dozen individual numbers which have no relation to anything else. They're not they don't come from this and a combination of that, like pi. They're just this number that appears in the universe and governs things. And if gravity was stronger, then we wouldn't get life on Earth. And if gravity was weaker, we wouldn't get life on Earth. Gravity had to be exactly the number that it is for us to be able to have life here in the way we understand it. And so the question that cosmologists wonder is, if you started back up from the beginning and started the universe again, would you end up with the same numbers? And the answer is they don't know. Could it be that there are multiple universes out there, and each one, every time it big bangs, it rolls the dice in different ways to come up with different numbers for each one of those variables? Maybe. Or maybe ours, the numbers that we have in this universe, there is some connection between them all and we just haven't discovered it. But right now, there doesn't seem to be any reason that the universe is laid out the way that it is, and it's just that if the universe was any different, we wouldn't be here to be able to observe it. So it had to be this way for us to be here to be able to talk about it. James Cutts. Hey Fraser, quick question. With NASA having to pay less to send astronauts into space by using Crew Dragon, is it likely that we'll see more funding for future missions to the moons in the outer solar system, such as Titan and Europa? Are there any missions currently being planned? I'm not sure NASA is going to save a lot of money using Crew Dragon as opposed to paying the Russians to get up the International Space Station. If you look at the budget for what SpaceX is charging NASA, they actually charge them a lot for the commercial crew program and for the Crew Dragon. So that's not really the reason why NASA is going with SpaceX and Boeing. It's to be able to bring that capabilities, to be able to get human beings into space back to the United States, which is a thing that, for the first time in 50 years, Americans have been unable to send Americans to space. So I think that's the primary reason. But that said, right, there is already a mission that's on its way to Europa. There's the Europa Clipper, and there are potentially a project in the works to send a mission to Titan, a helicopter, an awesome helicopter that would fly on Titan. And I've also heard plans of sending submarines and things like that. So I think we're definitely seeing a mission to Europa. That's in the works. It's going to launch within the next few years. And people are reasonably excited about sending a mission back to Titan to explore it more deeply. So the place that I would really like to see explored is the outer ice giants, right? Uranus and Neptune. They have only had one single flyby. Those, we need to go back and we need to learn more about them. Philippe Cavadon. Any way that our space junk ends up becoming a planet ring in thousands of years? Probably not. When you think about the space junk that's out there, the vast majority of it is orbiting so close to the Earth that it's being slowed by the atmosphere of the planet, and it's going to re-enter the Earth's atmosphere within years, decades, hundreds of years, thousands of years. It's only when you get much farther away into the thousands of kilometers in altitude that these things are going to last for a while. Could we come up with some time in the far future where the spacecraft have smashed into each other and created some kind of ring? Maybe. Or just all of the derelict junk. But my hope is far enough into the future we start to take this stuff more seriously, figure out ways to deorbit it, gather it, recycle it, reuse it. I mean, there's going to be a lot of really valuable metal sitting out in space that future civilizations are going to want to use for their space program. Mauricio Tugneri. Hey Fraser, can you explain why it said that the universe doesn't have a center? Thanks. No problem. Okay, first, the universe is either finite or infinite. So, if the universe is infinite, then it goes on forever, and so there's no meaning to the statement that the universe has a center, right? It's infinite. It's infinity in all directions. How do you say where the center is when it's infinity? So, we can take the infinite universe option, and that, I think, makes sense. So then you have the idea of the finite universe. And the way astronomers think about this idea of a finite universe is that the universe, right, is finite, it has some set size, but it still can wrap. So if you go far enough in one direction, you will return to your starting point. And if you go far enough in another direction, you'll return to your starting point. If you could see all the way through the universe, you would see the back of your own head, no matter where you looked. And so the question then is, what is the center of that, right? If you go some amount of time to return to your starting point, what is the center of that? And I'll give you an analogy, and I know, so imagine you're walking around the Earth, right? Imagine the surface of the Earth. What is the center of the surface of the Earth, right? What is the point? No matter where you go, you're going to walk the same amount of time, well, depending on the bulge of the Earth, and return back to your starting point. And so there's no concept of what is the center of the surface of the Earth. Now, obviously, when you think about it in 3 dimensions, there's a center of the Earth at the middle of the planet. And maybe if you could see our universe in 4 dimensions, you could imagine some center point of of our universe from 4-dimensional point of view. But our brains can't think that way. So either the universe is infinite, goes on forever, center doesn't make any sense, or the universe is finite, but it wraps, and the idea of a center doesn't make sense. Animus Australis. What's the latest considerably large discovery that's changed our understanding of the universe? Like the discovery about speeding up expansion. What are the hottest current research topics that may lead to revolutionary discoveries in the nearest future? I think you said it, right? Which is the discovery of dark energy. I mean, dark energy was this gigantic mystery that came out of nowhere that completely overturned our understanding of the way the future of the universe was going to work. Now we know that the universe its expansion is going to accelerate, and this was something that nobody expected. That said, I think the most productive field of research in space right now is extrasolar planets. I mean, 20 years ago, we found our first extrasolar planet, and here we are now. We know of thousands. We're probably within the next few years, we will know of tens of thousands. Probably within the next decade or so, we will know of hundreds of thousands of planets orbiting other stars. It's crazy, right? And at the same time, we're going to get better techniques to be able to analyze and study them, so that we're going to be able to see their atmospheres. We're going to be able to get a sense of what are all the different kinds of planetary systems that are out there, from planets, places with more planets than the solar system, places with less, the more massive planets, planets closer to the sun, hot Jupiters, icy Neptunes, super Earths, all these things that we don't have in our own solar system. So I think this is the place that is, we've just begun scratching the surface, and we're going to find out so much more information in the next few decades. I can't wait. Amza Baker. If the moon is moving away from the Earth and in time it leaves the Earth's gravitational pull, will it get pulled by another planet? And if not, where will it end up in the future? Right, the moon is drifting away from the Earth, but it's drifting so slowly that it really won't practically leave the Earth's orbit for the lifetime of the sun, for the lifetime of the Earth, and so within, say, I think it's like 50 billion years or something like that, the Earth and the moon finally become tidally locked to one another, but the sun is going to expand as a red giant, and it's going to potentially consume the Earth and the moon. But if the moon was able to escape the Earth, then it would just be in orbit around the sun. Then it would just become another planet, big asteroid, orbiting around the sun, and would do so for however long the sun existed. Maybe with some kind of crazy combinations, the moon could get pushed into some interaction with Venus or Mercury or Jupiter or Mars and could end up as a moon around some other planet, but that would be pretty complicated. A lot of the really interesting interactions in our solar system are gone. They happened billions of years ago, and now it's going to just be calmer and more settled down into the far, far future. So don't worry about it. All right, that was it. Again, awesome. I really enjoy doing these question shows. As always, if you have any questions while you're watching one of my videos or just some question about space, I can't wait to hear them. Just type them down in one of my videos. I'll gather them up and I'll answer them here. All right, I'll see you next time.